Hey friends, welcome to Code Explore. Today we are going to see a question of the day of Leetcode, that is last stone weight. So let's discuss the question. We have given an array in which we have given a weight of stones. Okay, so array of I denotes the weight of ith stone. Okay, yes. So what we have to do, we have to select two stones from the array which has larger weight. Okay, so for example, 8 has maximum weight, and what is the maximum weight after 8 is what? 7. Okay, so these two having a maximum 8, then we have to smash these stones and resultant will be the subtraction of their respective weights, that is what? Weight. Okay, so we'll remove 7, we'll remove 8, and we'll add 1 in the array. Okay, as we can see, 7 and 8 are converted to the 1. Okay, then we have a maximum 2 and 4. Okay, so we'll remove 2 and 4 and add resultant of 2 and 4 is what? 2. Okay, then we select 2 and 1 and add resultant of this is what? 1. Then we have 1, 1 and 1. Then we select 1 and 1. So now 1 and 1 both are what? Equal. So what we'll do, the resultant is what? 0. Okay, if the resultant is 0, then will not return that 0 in the array, or will not uh, write that 0 instead of 1 and 1 in array. Okay, like if the stones of same weight is smashed, the resultant is what? Nothing. So yes, and remaining will be what? Only 1. So last element in the array is what? 1, or the resultant of the all weights is what? 1. So our output is what? 1. Okay, so this is the question. So let's discuss the approach for solving this question. Okay, so there are two approaches. So first we will discuss the most optimized approach, which is using max heap. Okay, so what is max heap? So max heap gives the maximum element as a top element. Okay, like let's push this element in the heap. Max heap 4 1 8 1. Okay, so if we write x is equals to, suppose this is s dot top. So whichever is the maximum element present in the heap, that will be stored in the x. Okay, then we'll do x dot pop. Then we'll do x dot pop. Then we'll take y is equals to again s dot top. Then what is the maximum after 8 is what? 7. 7. So again we'll do y dot pop. Okay, now what we'll do, we do x minus y. Okay, and we'll push this resultant of x minus y in the max heap again. Okay, yes, like if x is greater than y, we'll push that resultant in the heap. If x is equals to y, then the resultant is what? Nothing. Okay, so this is the logic, and whatever the element remaining in the heap, last element remaining in the heap will be our answer. Okay, so let's write a code. Okay, yes, so we'll declare a max heap. Okay, then we'll push all our elements in this max heap. Okay. Now we'll run a while loop till our q dot size is greater than or equal to 1. Okay. We'll run while loop till a q dot size is what? Greater than or equal to 1. Okay. Now int x is equals to q dot top. Yes, then we'll pop that element q dot top. Int y is equals to q dot top. Again we'll pop that element q dot pop. Then if x is greater than y, x is greater than y, will push x minus y in q. Okay. Yes. Now if q is empty, then we'll return what? 0. Else we'll return q dot top. Okay. That is the last element present in the queue. Okay. So yes, so this is the code. One change. We'll run a while loop till q size is what? Greater than 1. Greater than 1. If the size is 1, that is our answer. Size is 1 means what? Only one element is present in the heap. So that is our answer. So we'll run a while loop unless the size of q is what? Greater than 1. So let's run the code. Try to submit. Yes. Okay. So this is the solution. So one more solution is there, which is using sorting algorithm, and which takes time of n square log n. Okay, so this is the solution. So what we'll do is, so here is the another solution using sorting algorithm. So firstly we'll sort a array. Okay, then we'll run a for loop from the last index to the first index. Okay, then again we'll sort inside the for loop, because every time we want the maximum element at the last. Okay, and what we'll do, we'll subtract our stones of I minus stones of I minus 1, and we'll store that answer at I minus 1th position. Okay, so this is also one approach, and the time complexity for this approach is what? For sorting, every time for sorting the time complexity is what? N log n, and for iterating the array, the time complexity is what? O of n. So time complexity will be n into n log n for this approach, and space complexity will be what? O of 1. And here the space complexity is O of n, and time complexity is what? N log n. Yes, so that's it for this question. So I hope you like the solution. If you like, subscribe to the channel, like the video, and share the video, and comment below if you have any another approach. Yes, happy coding.